In this video, we're going to look at completing the square for a quadratic function, and that means expressing the quadratic function in the form a multiplied by x plus p squared plus q. And expressing a quadratic in a completed square form enables us to do some more things. For example, it's much easier to find the vertex, which could be the maximum or minimum point of the graph. We can also see how the graph of the function can be obtained by translating the graph of y equals x squared. It's much easier to see the line of symmetry of the graph, and also we can use this method to solve the quadratic equation as well. So we'll see another method here for solving quadratic equations. So in the example at the bottom of the screen, we've got a quadratic function where the coefficient of x squared is 1, and we're going to complete the square. So we start with y equals x squared, take away 8x, add 3. And to complete the square, we take a bracket which we're going to square, and when the x squared coefficient is 1, we need an x at the start of this bracket, and we look at the coefficient of the x term. In this case that's -8, and we use half of that value. So we've got x take away 4 all squared. Now when we expand x take away 4 all squared, which I'll just do over here just to demonstrate for this first example, expanding that gives us x squared take away 8x add 16. So we automatically get x squared take away 8x, which is what we want to get because that's the first part of our quadratic function. However, we get plus 16, so I'm going to remove that by subtracting the 16, and then to ensure that we get the positive 3 that we want, we can add that on at the end. And so we end up with y equals x take away 4 squared, subtract 16, add 3, which simplifies to x take away 4 squared take away 13. And this is now in what we call completed square form. It's in the form that was mentioned here at the start of this video. As we've already mentioned, the completed square form of a quadratic function is extremely useful. We can see several things from it. Firstly, the vertex or turning point of the graph can be seen directly from the completed square form. If we look at the bracket first, we've got x subtract 4. That tells us that the x coordinate of the vertex is 4, and the value at the end of the completed square form there, the -13, tells us the y coordinate of the vertex. So we can see straight away that this function has got a vertex of 4, -13. Now another way that that might be expressed is to say that the minimum value of the function is -13, and this occurs when x is equal to 4. And the reason that it's a minimum value in this case is because this quadratic function has a positive x squared coefficient, and so the shape of the graph is going to be a U shape, and so therefore the position of the vertex is going to give us the minimum point on the graph. So that's why it gives us the minimum value in this case. We can also see that the position of the vertex is where the line of symmetry of the graph is going to be, and so there's going to be a line of symmetry at x is equal to 4, and we can get the y-intercept by either referring back to the equation in its original form, which was x squared take away 8x add 3. So we can either substitute x equals 0 into that form of the equation, or we can substitute x equals 0 into the completed square form of the equation, and that's going to give us the y-intercept as 0, 3. And if we use the information we've got so far to kind of put the sketch together for the quadratic graph, as we've done there on the top left, we can see that the graph is the same as the graph of y equals x squared, except the graph has been translated, and it's been translated by moving it 4 units to the right and 13 units downwards. So we can say that the graph of y equals x, take away 4 squared, take away 13, is obtained from the graph of y equals x squared by a translation of 4 negative 13. So there's a couple more examples at the bottom there. If, for example, we started with the graph of y equals x squared and then translated it to produce the graph of y equals x plus 5 squared plus 7, that would require a translation of negative 5, 7, so that would be 5 units to the left and 7 units upwards. Alternatively, you work the other way, you start with the graph y equals x plus 5 squared plus 7, and you want to translate that to produce the graph of y equals x squared. You would go the other way, and that would be a translation of 5 units to the right and 7 units down. So in this example, we will complete the square, and from that we'll be able to see the vertex of the graph and identify the line of symmetry of the graph, and from that we can draw a sketch. So completing the square, we need x plus 3 squared to begin with. We're going to need to subtract 9, so that we're only left with x squared plus 6x when we expand the x plus 3 squared, but we also need to ensure that we have negative 3. So we can tag that on the end there and get the completed square form of y equals x plus 3 squared, take away 12. Now from that we can see that the vertex of the graph, we can identify that from the two values here. The vertex of the graph is going to be negative 3 for the x coordinate and negative 12 for the y coordinate. What we essentially do there is we look at the value we've got here and we take the negative of that for the x coordinate, and the value here gives us the y coordinate of the vertex. And if that's the vertex of the graph, the line of symmetry of the graph must be x equals negative 3. We can also see fairly quickly from the original form of the equation that the y-intercept of the graph is y equals negative 3. So putting that all together on a sketch gives us a picture of our graph with all the important information on. The only thing missing from that sketch are the roots of the function, and we could calculate those. In this case we would use the quadratic formula, and that would generate the roots, and you're going to get x equals negative 3 plus 2 root 3, and x equals negative 3 take away 2 root 3. The difference in this next example is that we've got an odd number for the coefficient of x, and that means that we need to use fractions when we complete the square. And there's a note there that says it's important to use fractions, not decimals, and that goes for most topic areas at A-level maths. It's preferable to use fractions rather than decimals when we are showing our working out for various things, and that is certainly true here. So if we complete the square, we're going to need x plus 5 over 2 squared Now we need to subtract 25 over 4, which is the square of 5 over 2, and then we need to add 7. And so the completed square form is y equals x plus 5 over 2 squared plus 3 over 4. And so from that we can identify in the same way as we did before that the vertex of this graph is negative 5 over 2, 3 over 4, and that the line of symmetry is the line x equals negative 5 over 2. We can see from the equation, the original equation of our function, that the y-intercept is y equals 7. And if we just label the points for our vertex, x coordinate negative 5 over 2, y coordinate 3 over 4, that's going to produce a U-shaped quadratic graph because the coefficient of x squared is positive. And if we draw that in, that's going to look like that. Okay, this graph clearly has no roots because the graph does not cross the x-axis. And we can also see that by looking at the completed square form of the equation. So if we look at that in a little bit more detail, x plus 5 over 2 squared plus 3 over 4. Now, when we square something, we always generate a positive value. So this is always going to be greater than 0. And then if we add 3/4, that's obviously still going to be greater than 0. And so therefore y must be greater than 0 for all values of x. And we can see that from the graph as well. Now, many students find it quite difficult to complete the square when the coefficient of x squared is not equal to 1. Now there are two slightly different approaches to completing the square when the coefficient of x squared is not equal to 1, and we'll look at both of those methods on the next two examples, and then you can decide which of those two methods you prefer to use. So firstly, the first method is that we take our quadratic function, and in this case we've got a coefficient of 2 for the x squared term, so we're going to take out a factor of 2 to leave x squared, subtract 3x, add 1, and then we can complete the square with the part that is inside the bracket. So that gives us 2, and then if we complete the square here, we're going to get x, take away 3 over 2 squared. Now we need to subtract 9 over 4 because that's the square of 3 over 2, and then we need to add on the 1. And so if we simplify that before we continue, we've got x, take away 3 over 2 squared, and take away 5 over 4. And finally, we can multiply out by the 2 again to give us 2 multiplied by x take away 3 over 2 squared, and then take away 10 over 4 or 5 over 2. So we've completed the square successfully when the coefficient of x squared is not equal to 1. So that's method 1, which is to begin by taking out 2 as a factor because 2 was the coefficient of x squared, and then complete the square within the bracket, and once you've done that you can multiply out by 2 again. So I'm going to use the same example again just to show you a slightly different approach to doing this, and this different approach works by doing 2x squared minus 6x, and then we're going to kind of leave the plus 2 until later on. And I'm going to take a factor of 2 out of the first two terms. but we're kind of ignoring the other 2 for now and just leaving that until the end. And then we can complete the square on the bit inside the bracket. So that gives us x take away 3 over 2 squared, subtract 9 over 4, and then we've got our plus 2, which we'll deal with at the end. And then we can multiply the part in the square brackets now by 2 to give us 2 multiplied by x minus 3 over 2 squared, and then we're going to multiply 9 over 4 by 2, which gives us 9 over 2, and then finally we've got our plus 2, which we're going to deal with now by adding that onto our negative 9 over 2. And so we end up with 2 multiplied by x minus 3 over 2 squared, and take away 5 over 2. So we get the same answer, it's just a slightly different approach. Now there are some questions at the end of this video for you to try, and the questions at the end of the video use this approach, which is to leave the constant term until the end. However, if you prefer the first approach, then by all means use that. Just bear in mind that the solutions to the questions at the end of the video are using this approach. Now you can also use the method of completing the square for solving equations. So in this example, we're going to start by expressing 3x squared take away 7x plus 1 in completed square form. We're then going to use our completed square form to solve the equation. 3x squared take away 7x plus 1 equals 0. And finally we'll sketch the graph of the function as well. So for part A, I'm going to use the second approach of those 2 examples that we saw just a moment ago. And so I'm going to write 3x squared take away 7x plus 1. But I'm going to leave the plus 1 until later, and I'm just going to do 3x squared take away 7 over 3x, and then the plus 1 I'm going to leave until the end. Now if we complete the square on the part in the bracket, that's going to give us x take away 7 over 6 squared. Now we need to subtract 49 over 36, and then we've got our plus 1, which we're going to leave until the end. And multiplying that out is going to give us 3x take away 7 over 6 squared, take away 49 over 12, and then we've got to add 1. And so we get 3x take away 7 over 6 squared, take away 37 over 12. Now for part B, we're going to use the completed square form of the equation to solve the equation. 3x squared take away 7x plus 1 equals 0. So that's the same as saying 3 multiplied by x take away 7 over 6 squared take away 37 over 12 is equal to 0. And now we have it in completed square form, we can simply rearrange this equation to make x the subject, and that will give us our value of x, or values of x. So 3x take away 7 over 6 squared equals 37 over 12. If we divide by 3, x take away 7 over 6 squared equals 37 over 36. So if we continue with the rearrangement, we get x take away 7 over 6 must be positive or negative square root of 37 over 36, and so x must equal plus or minus the square root of 37 over 36 plus 7 over 6, or in other words, positive or negative root 37 over 6 plus 7 over 6. And since we've got a common denominator there, we can write that as plus or minus the square root of 37 plus 7 all over 6. And so for the final part, we can now produce a sketch of our graph. And we can see from the completed square form of the equation that we've got a vertex at x equals 7 over 6 and y is negative 37 over 12. So those 2 points have been labelled on the sketch. From the original form of the equation, we can substitute x equals 0 and quite quickly see that the y-intercept is 1. So again, that's been labelled on. And then the two roots we found by solving the equation. So we've got those as negative root 37 plus 7 over 6. And the other root here was positive root 37 plus 7 over 6. You can get from your calculator the approximate values of those. That is approximately 0.15 and that is approximately 2.18. So it gives you an indication of the approximate values for when you're drawing your sketch. So here's 3 questions for you to review your understanding. So have a go at these 3. You need to complete the square, sketch the graphs, labelling the vertex and all the intercepts on both the x and the y axis. Once you've had a go at them, you can continue with the video and you'll see the solutions to these questions. So here's a solution to the first one. We can see from the completed square form of the equation that the vertex is at the point 2, 15. And since this function has a positive coefficient of x squared, it's a U-shaped graph. And with the vertex being above the x-axis, that must mean that there are no roots to this equation. And you can see the sketch graph on the right hand side there with everything labelled as required. You might find this example a bit more tricky because it's got a negative coefficient of x squared. So we can deal with that. First of all, I'm just going to rewrite that as negative x squared, take away 3x plus 6. Now, if we take out a factor of negative 1 from the first 2 terms, then we've got x squared plus 3x, and then we've leave our plus 6 until later on, and then we can complete the square for the pi in a bracket. So we get x plus 3 over 2 squared, subtract 9 over 4, and then we've got plus 6. So that becomes negative x plus 3 over 2 all squared plus 9 over 4 plus 6, giving us negative x plus 3 over 2 squared plus 33 over 4. Now we can solve to find our roots. So negative x plus 3 over 2 squared plus 33 over 4 equals 0. So if we rearrange, we're going to get x plus 3 over 2 squared equals 33 over 4. So x plus 3 over 2 is going to be positive or negative square root of 33 over 4, and that's going to give us x equals positive or negative root 33 take away 3 all over 2. Now for the purposes of drawing our sketch, we can use a calculator to see that the approximate values of x are x is approximately equal to 1.37 and negative 4.37. That's written to 2 decimal places. And using all that information produces the graph on the right, and we've labelled all the points there. The vertex of the graph we can get from the completed square form of the equation as an x-coordinate of -3/2 and a y-coordinate of 33/4. The y-intercept we can get from the original form of the equation by substituting x equals 0, so that's y equals 6, and the two roots have both been labelled on there as well, that we've just found by solving the equation. And here's the full solution to the final part of that question. So on the top left is the working out for completing the square, and from that we can see the vertex and line of symmetry of the graph. It's a positive x squared graph this time, so it's got a U shape. The bottom left shows the working out for solving the equation to find the roots, and then you can see the diagram there, the sketch diagram of the graph with all the information labelled on as required. So here's some practice questions. The first section, question 1, the coefficient of x squared in all of those equations is 1. So expressing each of those in the form x plus a squared plus b. And for question 2, the coefficient is not equal to 1. The coefficient of x squared is not equal to 1. And there's an additional challenge at the end. So have a go at a good selection of those questions, and then when you're ready you can continue the video and the solutions will appear so you can check your understanding. And here's the solutions.